Hello friends, let us continue solving problems on quantization. In this session, we will derive the 6 dB rule of PCM for a full scale sinusoidal signal, and we will use it in solving a problem. Let us first derive the 6 dB rule of PCM in the form of a problem. The problem statement is as follows. The output signal to quantization noise ratio SQNR in a PCM system is defined as the ratio of average signal power to average quantization noise power. So this is the definition of SQNR. If L represents the number of quantization levels and R represents the number of bits per sample for a full scale or full load sinusoidal signal with amplitude A, show that the signal to quantization noise ratio at the output is 3/2 L square or 1.5 L square, or equivalently, when expressed in decibels, the signal to quantization noise ratio is 1.76 plus 20 log L to the base 10 or 1.76 plus 6R, and this is known as the 6 dB rule of PCM. We will derive it. So this is known as the 6 dB rule of PCM for a full scale sinusoid. Now what do we mean by a full scale sinusoid? A full scale sinusoid is one with equal positive and negative peaks. So this is a full scale sinusoid with the positive peak as A and negative peak as minus A, so that the dynamic range of the signal is 2A. We know that for such a sinusoidal signal, the average signal power S is equal to A square by 2. It's a well-known result. And the quantization noise power NQ is equal to delta square by 12. This is the quantization noise power for PCM, assuming uniform quantization. So the signal to quantization noise ratio is then given by, so the SQNR S by NQ is equal to the signal power, which is A square by 2, upon the quantization noise power, which is delta square by 12, and that is equal to A square by 2 into 12 by delta square, that is equal to 6A square by delta square. Now we know that delta, the step size in uniform quantization, is given by the dynamic range, that is 2M max, where M max here is A, so 2A by the number of quantization levels L. Substituting this value of delta in this expression, the signal to quantization noise ratio becomes 6A square on delta square. Delta square will become 4A square by L square. A square and A square will cancel, and what we get is 3/2 L square or 1.5 L square. This is the first part of the result. We were supposed to show that signal to quantization noise ratio at the output is 3/2 L squared. Now when expressed in decibels, S by NQ in decibels is equal to 10 log to the base 10 of this quantity, 1.5 L squared, which is equal to 10 log 1.5 plus 10 log L squared. 10 log 1.5 is approximately 1.76 plus, here we can write it as 20 log L to the base 10. So this is another result. We have shown that signal to quantization noise ratio in dB is 1.76 plus 20 log L. Now further, each quantization level L is equal to 2 to the power R, where R is the number of bits per sample. Substituting this value here, we get 1.76 plus 20 log to the base 10, 2 to the power R, or 1.76 plus 20 R log 2 to the base 10. And now log 2 to the base 10 is approximately 0.3. Thus, we get finally the signal to quantization noise ratio at the output in dB is equal to 1.76 plus 20R into 0.3, which is equal to 1.76 plus 6R. And this is called the 6 dB rule of PCM. That means for each additional bit used for representing a sample, the signal to quantization noise ratio increases by 6 dB or it improves by 6 dB. Let us now use this result in a problem. So the problem statement is as follows. Consider a binary PCM system in which the output signal to quantization noise ratio SQNR is to be held to a minimum of 40 dB. Determine the number of required quantization levels, the number of bits per sample, and the corresponding output SQNR for a full scale sinusoid. So first thing to be noted here is that we are talking about a full scale sinusoidal signal. So what is given is that the signal to quantization noise ratio SQNR must be greater than equal to 40 dB. And because a full scale sinusoidal signal is given, the SQNR, which we just found as 1.76 plus 6R, so this must exceed 40. From here, R must be greater than equal to 40 minus 1.76 whole divided by 6, and that comes out to be 6.36. But R, which is the number of bits per sample, must be an integer greater than this number 6.36. So R must be equal to the ceiling of 6.36, which is equal to 7 bits per sample. This is one result. With R equal to 7, the number of quantization levels L equal to 2 to the power R equal to 2 to the power 7 is 128. So the next result. And finally, the third thing asked is the corresponding output SQNR. The actual SQNR is equal to 1.76 plus 6R equal to 1.76 plus 6 into R is 7. It is 6 into 7 is 42 plus 1 43.76 dB. So the actual SQNR achieved is 43.76 dB, which is of course greater than 40 dB, the minimum required. So I hope this problem is clear and the derivation of the 6 dB rule of PCM for full scale sinusoid is clear to you. Thank you.